We are live. Welcome everyone to Isaac and Zach's Code Jam. Today we're going to be looking at state machines and especially XState. And I think we're going to start with a presentation that Isaac's prepared for us.
Yeah. So Zach, I can't actually see you, so you'll have to let me know if I'm doing something strange. So yeah, so
you look good, Isaac.
All right, awesome. So this is a little presentation about why I like state machines and specifically XState. State machines are really helpful for a few reasons. State machines are an old computer science idea. They've been around for decades, so it's not a new some new concept, some new framework. Even though XState itself is only a few years old, the state machines also help you to plan out what your code is going to do, and anything that helps you plan before you act will make for better code. I also like that state machines using so a visualizer tool lets you interact with your code in a visual way. And sometimes there are some problems that are really helpful for me to think through in a way that in a visual way rather than typing it out in code. And I can see the problem a lot easier that way. So in general, state machines are a way of describing the specific states your component or your application go through, and describing the transitions between them, how you go from this state to the next state to the next state, and what changes as you move through those states. So I want to compare state machines to standard component state, a local component state, and to Redux or NGRX pattern. So component state is local. It's only inside that component, and it's changeable from anywhere inside the component. Any function in the component can change that state to anything you want it to be. So it's localized, but it can be changed at any time by anything inside that component. On the other hand, Redux or NGRX it's global. It can be accessed, and a change could be triggered from anywhere. But those changes can only happen by specific events. In NGRX, we call them actions, but they're events that get dispatched to the store. But inside that reducer, your state can be changed to anything you want it to be. There's no restrictions on how that state changes, as long as it's being changed inside the reducer. Mm-hmm. So to contrast here, component state is local, changed from inside the component to anything. There's no restrictions on that. Redux is global, changed only by specific events, so only through the reducer, and then inside the reducer it can be changed to anything. So state machines is like component state. It's local. It's changed inside of that state machine, and usually state machines are connected to one component, Yeah, so one component. It could be a big component or it could be a small component, but just one component. And it's not accessible globally. But it's also like Redux or NGRX. It's changeable only by specific events. You send an event to the state machine, and then the state machine decides what to do with it. But unlike Redux, you have some restrictions on how you can change your state. The reducer can do whatever it wants to the Redux state, but in a state machine, the state can only change to another predefined state in that state machine. You can't change the state from state 1 to a chicken, because the chicken is not defined as the list of states in your state machine. Whereas in Redux, you could do that. You could do whatever you wanted.
Right. So as part of the advantage then of using a state machine, we're going from something that's infinite. We can change it to whatever we want to now finite.
Right. So there's an advantage because of that, because you're restricted. There's also, it's restrictive as well. So there's some things that you can't do as well inside of state machines that you could do in Redux. yeah, because it's restricted, it gives you some other powers that we'll get into. So one thing I want you to know is that you're already using state machines, and you may not know this, but they're in your code. Some of them are just poorly defined state machines, and that they have bugs in them. But if you use a framework to manage your state machines, like XState, to help you explicitly list out your states and have an explicit way of going between those states, that makes the state machines that you're already using less buggy. So I tweeted this out yesterday. The 6th Sense boys saying, "I see state machines, but they don't know they're state machines." So they're in your code, walking around like dead people. Yeah,
I liked it. It's very true, I think.
Okay, so here's how to see a state machine inside of your code. If you have multiple related booleans in your application, like is loading and is error and I don't know, is loading, is error, is successful, all those booleans that are all working together. If you have a series of conditionals that all use the same booleans, that's probably a state machine. If you have an enum that defines a sequence of things, like you have a variable that goes through a progression of enum values, that's probably a state machine. Or you have a UI that goes through a series of steps, then that, like a wizard or something like that. You can model that really easily with a state machine.
Mm-hmm. Well, let me ask Isaac. One thing I've noticed, and I do this a lot too. Inside of a Angular component, let's say, I have a property on that class component, or the component class, that is called state, but it's really just an enum, for example. And there's other class properties on that component class that are also contributing to, like, state in a larger sense of state.
Right. So that you have some rules, or usually you have some rules around that enum. You say, hey, when you're in the initializing state, then this other value needs to be false. And then when you're in the successful state, this other value needs to have an array in it with some values. Or so you have these implicit rules about how these things work together, and you have to, every time you come to that code, you have to remember what those rules are, or you'll screw something up. You'll get a bug in your code. And state machines help with that as well, because you say, here, these are the explicit things that happen in these states, and we can get into that.
Yeah, that's interesting. I feel like a lot of what I put into constructing this code is making it so that someone can see, for this implicit state machine, how things interact, trying to code things nice and cleanly so that it's all in a functions or a method to show, in this state, this is how things should be. But I never go out and explicitly say it.
Right.
It looks like this would be a great tool to actually do that. And thereby communicate it better, I think, to other people coming behind me. So
this is an example from real life. So my kids have bike locks like these, where you have a lock here that has words on it. You can twist the letters to spell a word, and if you spell the right word, that's the key for unlocking it. Then you can pull it apart and take it apart. So if you were to look at this and make a state machine from it, you want to ask these questions. You want to ask, what are the states that this object can be in? What are the events that this system cares about? And then based on those events, what are the transitions between states that we want to do? Actions we can get into later. Those are basically things that happen that aren't just moving from one state to another. It can be updating a value inside the state machine. It can be notifying your component that something's happened, or just calling a function somewhere that's outside of the state machine. And then context, the term context stands for data that's inside of your state machine that's not a state. That's not the actual state itself. So it could be something like in this case, the context could be the letters that are being spelled out. So like LOOK could be the current state of the letters on the lock here. So let's talk about the states here. What states are in this system, Zach?
Well, it looks like you have your 4 rotaries, I guess, there. So I would think you probably have the position of each rotary being a state. So 4 of them in this case.
Yeah, let's take a step back from that.
Okay.
Just assuming, let's just pretend that this is a really simple lock that has just a toggle on and off, basically. So pretend it's just one flip to lock it or unlock it.
Okay, that sounds like a nice lock, but
yes, it's a perfect lock.
Nice. Yeah. So I imagine then we'd just be looking at either a Boolean or an enum that's like locked or unlocked.
So there's locked and unlocked. There's also whether the system itself is the cable is connected or unconnected, open or closed, right?
Okay. Yeah.
So we got 4 kind of states here.
So those are really kind of 2 Booleans, but now we have like taken the cardinal product of those. So now we're at 4 different possible states.
Yeah. So it's locked, unlocked, closed, and open. But also closed kind of locked and unlocked really only makes sense in the closed context. So if it's closed, then it can be locked or unlocked. If it's open, it's by definition unlocked, right? Open and locked doesn't make any sense.
Okay. So that's something. If we were just using Booleans already, we may not be defining it properly.
So if we had is open is true and is locked true, then that doesn't make any sense. Right. So we can define it as, okay, we've got open as a state, we've got closed and unlocked as a state, and closed and locked as a state.
Right.
And then we can define the events that transition between them. So events, we can have an event that is open, an event that is close, an event that is twist, I guess, for twisting the lock.
Right. And
so different states will react to those events different ways. So if it's locked and you try to open it, that's not going to work. It won't go anywhere. But if it's closed and unlocked, open will take it to the open state.
Right.
Yeah, I think that's enough talking at a picture. Let's look at some code.
Let's do it.
Okay. So I have here a simple Angular component that mocks out a network call, and sometimes it'll return a successful network call with this array of data here, and sometimes it will return an error that says, error, I sense a great disturbance in the network. So this is Star Wars character data. That's why I have Star Wars themes in the error messages.
Nice.
So let's make this a little nicer by letting people know when it's loading. So let's do is loading. Is a Boolean, so let's set that to false, and we'll do is loading, set that to true here, and then we'll do when this finishes, pipe with a tap. Come on, I'll have to import XJS operators. There we go.
Cool.
People, and then is loading. I guess it doesn't matter what people is.
Yeah.
And then we need to set this to this dot is loading.
Right.
And then in the app component, we'll say we'll put in a div here, and we'll say loading message, and we'll have an ngIf.
Cool.
Loading is loading. So is that, and then here let's do a UL. Let's just make this a little easier to look at. LI. ng4 equals people async let person of that, and this is person dot name, I think.
Cool.
We went there. Okay, so let's see if that worked. Okay, so fetch, so displays loading, and then it looks like we didn't set loading to false correctly, but it's displaying this. And if we fetch again, there's an error. I need to show an error message. Okay, let's update that. This dot is loading equals true. Here we go. I need to set this to false. That's why is loading didn't go away. And let's do a is error here, or let's say let's do error message maybe.
Okay.
Error message. That's an empty string, and then we'll do a catch error here. Error. This dot error message equals error dot message. Try that. So we'll add an error message. All right, let's see if that does what we want. So this is what I usually do when I'm doing a network call. I think about, okay, so is it successful or is it an error? Let's see, type error defined. So I'm returning I need to return an observable here. Let's see, do return throw error with error. I think that's what you do. Okay.
There you go.
Starting it. So it threw an error successfully, but it did not update our error message. Instead error message equals error message. That's console log here. We have to click a few times until we get an error. Okay, so I don't have to do error.message. It's just,
you just do error. Yeah.
Just do error. Yeah. Okay, so I think this is working, and we have about 10 minutes left to try to make a state machine for this.
Yeah. So what we've done right now, we've kind of done what we talked about, where we have our Boolean that shows us if we're loading or not, and now we have a string that is representing the error message should an error occur.
Right. Yarn add. I should have done this beforehand. And you know what? I think I will just skip this, and I'm going to go straight to the XState visualizer here, and we'll do our work here. Actually, so when you go to the XState visualizer, it's a bigger URL here. They've got their default state machine is a network request, And so why don't we just use this one?
Okay.
Because it has an idle state where you're starting, and then the fetch event will take you to the loading state, and then you can resolve to get to success, or you can reject and get to failure, and then failure will let you retry to go back to loading. So let's just use this actually. So it's really nice here to see, instead of having those Booleans where you have to do is loading and is error and is success, or is loading and is error, and then you have to figure out how to combine those Booleans to get to success.
Right.
You can just see, hey, we got 4 states here, and we didn't even think about the idle state. Like we're not doing anything for that right now.
But it definitely still exists in what we just wrote.
It still exists, but we're not doing anything, and maybe we want to. If we see it there, it'll remind us, okay, maybe we want to account for that.
Right. So looking at the code here, what's happening is you're creating a machine, right? And just basing that off of a pretty much a plain old JavaScript object, right? That's right.
So I'm going to put up in VS Code here because it'll be easier to see. We'll call it fetch machine.ts.
Cool.
And we will import machine from XState here.
I used to rage against the machine, Isaac, and then here I am importing the machine.
That's right. You're just a cog in the machine now. So in the machine here, we've got these are the important pieces here. So we're giving it an ID, which is just whatever string you want to give it, an initial state that it's going to start in, and then we define our states. We've got idle, loading, success, and failure.
Okay.
So then inside of idle, we're saying what events should it respond to, and so we're listening for the event fetch, and then once you get to hear the event fetch, then it's going to go to loading. Then inside of loading, it's going to listen for resolve and reject. Resolve will take you to the success state. Reject will take you to the failure state.
Right.
Success, it's got a type of final, but we can ignore that. We don't need to worry about that. And then failure. Failure is listening for the retry event. And this has a slightly different syntax. So this syntax up here is a shorthand for this object notation. So that's those two are the exact same thing, but the object lets you add a few extra things on here. But we'll ignore that for now because we have 7 minutes.
So really what we're doing is we're defining our states, and we're saying for each event, this is how we transition from state to state, right?
Exactly. And so these transitions here correspond to these arrows. Right. So the capital, all caps words here are the events, and the arrows are the transitions. Right. And the boxes are their states.
And this visualizer here is generated based off our code, correct?
Exactly. So we could rename this to pending, and rename all the places that reference it to pending, and click update here, and it's renamed up here.
That's awesome.
So yeah, it's pretty cool to be able to do that. Okay, so I've got this, and let's see if I can, in 5 minutes, import. Okay, so I'm going to do fetch. Let's see. Import from fetch machine. Got the wrong one.
So now we've defined in that other file our machine. So now we're just importing that machine that we defined.
We're importing that machine that we defined, and then we're going to use it in here.
Awesome.
So we're going to do import interpret from XState. And we can do, so we could define this as an Angular service if we want, but interpret fetch machine dot start, and then let's see, let's call this state. I don't know, call it fetch state, I guess. Equals, and then we're going to feed this service directly into a observable. Let's see, and why is this not working? Service. Okay, I'm going to double check the example code again. Recipes used with RxJS. Service interpret. That is supposed to work. Import from RxJS. Okay, so why is this not working?
Oh no.
Yeah. Okay. State TypeScript errors are hard to debug.
Right.
Let's try this.
There
Nothing can go wrong.
When in doubt.
Yep. Okay, so let's actually we'll take this fetch state and put it inside of our component here.
Okay. So what is this observable of? Is this of our current state, or is this?
Yes, it's an observable of our current state.
Okay.
Kind of with some extras around it.
Okay.
Let's save that. And so inside of here, we can do fetch state, async. Let's see, how do I do this? We'll do a div here and get a reference to the actual state inside of it. So do the ngif as async as fetch state, and then we'll do fetch state dot matches loading. Cool. The state of loading. Okay, there we go. So this should output true when we're in the loading state.
Okay.
And then nothing otherwise.
Gotcha.
So let's, and then actually, hold on. You know, let's just do this. Instead of doing dot matches, we're just going to do pipe it to JSON.
Okay.
Because
that way we'll see the entire.
That we'll see what's going on. Okay. Invalid object where a stream is expected. Okay, so calling it any didn't work. Usually it doesn't.
I wonder if it has something to do with taking out those actions there. No, I don't think so.
Service dot, let's see. Start dot subscribe is there. Okay, well, here's what we'll do. We'll do let's see, new we'll call it subject, and we'll do
so we're going to call next on our subject whenever we hear the service change state. Okay.
Constructor service dot subscribe and state. And I'm sure there's a cleaner way of doing this, but next state.
Right.
That should at least get us something visible. Okay, console. Okay, it is not displaying anything. And why not? Fetch state.next. We'll console log the state here.
Oh, I think we named our fetch state wrong in the JSON pipe. I think we need a $sign right there in the template.
We're doing fetch state async as fetch state here.
My mistake.
So that's there. Well, okay, so let's do this. We'll send some events to the service dot. Where is it? Send. There it is. Send.
Yeah.
Send, and we're going to send a event of fetch.
There we go. Yeah. So because we were doing it that way with the subject, we're never really calling next on that subject without doing something to the machine.
Okay.
I think that's probably why we saw it there. So when we
yeah. So we would need it to be a behavior subject,
right,
with the service
with the initial
state there. That would do it.
Mm-hmm.
There it is. Okay. Okay. So we've got some values in here, but we will have to be continued this, I think, because we're at the end of our time.
Well, I mean, we explained the problem. We saw how you could solve it. We got into it a little bit. But yeah, I think this would be a great place to pick up on next week. Try to get into it more, see what was happening wrong with why we couldn't just turn that into an observable, because that seems like it would be extremely helpful just to say here's an observable stream of what that state is.
Right.
Yes, that state's being managed in a completely different file, actually. So yeah, cool. Sounds good. Well, thanks everyone for watching. Thank you, Isaac, for the presentation and
Sure.
That was fun. We didn't get too far, but we did a good amount, I think.
Yeah. All right. Next time we'll actually display some state values.
Sounds good. Sweet. Thanks, Isaac. Thanks, everyone. See you next time.
Bye.